Okay.
All right.
All right. We have our online participants. Okay. Question is, what's on the one item on your big team science kind of accelerating these sorts of open science practices wish list? What is it that you want? Is it funding? Is it policy change? Is it like what's the one ask that's going to enable us to move forward in the field in a faster and more effective direction towards these goals that we've all been articulating? So I'm happy to have anybody jump in and start on that, online participants or kind of previous presenters.
Just do it. No, I mean, I do think there are lots of infrastructure pieces that we need to change. Some of the funding, we need to have funding streams for things like replicability studies and for data curation. But I think what I really appreciate about Psych Science Accelerator, the Look at Big Keep, Many Babies, and all these other projects is there are folks who are just doing it. You folks are just doing it, and you're doing it now. And that's how the culture changes, is by people just doing it. So keep doing that, right? And pretty soon, this will be the way. I mean, this is one of the ways that science will go forward. Not every study has to be big, right? There's still lots of room for smaller scale studies, but the ways that big team science drives innovation and openness and policies, I think, is going to trickle down. I mean, certainly has in other smaller scale studies that I've done. So that's my mission. Just keep doing it.
This maybe is a cheap answer because it's not just one thing, it's kind of a category of it, which is as much as we can do to change the incentive structures on things, I think is a big deal. And so an example is, the more we can do to credit and value being the middle author on something. And I know there's things to do with this, but like the more we can do to do that. And then on the other hand, the costs of stuff, like the thing that comes immediately to mind is just wrestling with all sorts of IRBs and all of their idiosyncratic reactions to things. So changing the incentive structures of reducing costs and increasing benefits for trying to do these things would be huge.
I mean, I'll say funding. Because I think that for me personally, it seems like there are some folks who are able to just do it, and some of us are lucky enough to be in that position, and then others really aren't. And so I really like it to be that everyone is able to do that, and without funding that we can pass to the people who maybe situation is less facilitative of that. Yeah, we need funding to be able to make it so everybody can do it. If they want to, they should want to, and then we'll all sort of be on a more level playing field.
Yeah, absolutely. I guess it was glib to say, that we have to have resources, right? And that's important. So, but I guess what I hope folks come away with is an appreciation for how much progress is being made, and that there are lots of problems that just seem impossible to solve. That now we kind of know how to do these things, and so you don't have to reinvent necessarily all of it. So that's right. And so yes, and someone who has money, I'm happy to bet their ear about a specific proposal I have that would help in this area. So I'm happy to talk to them.
Well, I was saying in our small group that we got some grant feedback. One of our folks, Nicholas, I believe, and this is not my story to tell, Nicholas, but I'm going to tell it anyway. Some feedback is sort of like, well, you guys have been doing so well on no money. Like, why would we give you money? Sort of like, well, because there's only a few people who can, the fact that we did it on no money is kind of a,
right.
It's an illusion.
So my personal experience with this is there are people who are really good at navigating the funding environment, and I consider myself, I've been modestly successful on my own. I've been far more successful with people who just keep those calls for lunch and know how to respond. So if you haven't engaged some of those people that can be recognized, these people really know how to get money. That would be my advice. I think one of the problems with many babies, I mean, so I've been asked to review many babies proposals, and I look and I say, I'm conflicted out. And I wonder whether some of the challenges with some of these proposals is you're so inclusive that people who actually know enough to be, well, people who know enough and will review the project in a supportive and enthusiastic way are conflicted out. So I can imagine that being a challenge. So anyway, I'm happy to help in any way that I can on that. I point you to some folks that I have gone through with.
Okay, I think I see a couple of hands. This has seeded some ideas. So now our goal was to open things up to the broader audience. So please go ahead.
I just first thank everybody for it. I think that was really, I'm very good. I have a kind of comment about how and I think we might want to think about undergraduates and as and the reason I'm saying it is because I do encounter quite frequently that undergraduate society don't have the technical background for all of this. And they just have reluctance to try all these. Well, I don't know anything about this, but I don't want to touch it. I don't know how that works. And not only that, their institutions would something I don't think so was applying for jobs. That institution said we will not teach our graduate students class statistics and graduates coming on. We will do them as process only. That's how we do it. So is there a way maybe to engage in undergraduate workshops? Something that's have an expectation and they won't feel intimidated by learning to use Ruby to program data like that, so that they are inclined to participate as opposed to
Thank you so much. One very practical way to answer this is that a few of us have been talking about and are applying for funding to get support for a Many Babies summer school. And we hope to be able to make this happen. And this could be, it'll be virtual, it'll be broad and inclusive, and it will certainly involve undergraduates who are enthusiastic about the field, right? And much as I'm so pleased to see so many graduate students and postdocs in the room today, you all are the future of the field, and you got to, I don't know, take some of the traditions of yesteryear out the door and do what you think is best for this field. I really hope that undergraduates would have the opportunity, no matter where they are, what institution they're in, right, what nation they're in, to join this. And we have a list of a couple dozen ideas for different topics and panels, including basic training in statistical programs and some of the data management stuff that was raised today. So that's one concrete way to enter this, I think. That might open some doors and make it an actual entry point to then furthering your education, perhaps in practice.
I have my hand raised. I don't know if I can just jump in, but maybe I have something to add.
Yeah, go ahead.
Okay, I was just, it's funny, I teach a developmental lab course, and today we covered the Many Babies 1 paper, and we looked through the open science framework, and we looked at Databrary and all of the wonderful examples of the lab walkthroughs, and my students were really excited about all of this. I wonder if, given, how many undergraduate programs in psychology include, if not just a developmental psychology intro class, but also a developmental lab class or some sort of methods class. I wonder if folks who are interested could put together like a module about Many Babies or about open science practices or about big team science that could be distributed to professors who are interested in spending, adding it to their syllabus, providing, content already sort of curated that could give undergraduates an introduction to kind of the big ideas and sort of in a ready-made package such that, they could learn and appreciate the material too, and then also have it in such a way where they could incorporate it into their syllabus and as a unit.
Yeah, thanks for that. That's Molly. I think that's a great suggestion, and it's something that I think about a lot in my own pedagogy. So I primarily teach graduate students in a lab methods class. But so the centerpiece of the class is doing an independent replication yourself. So you pick something from the literature and do a replication study, collect new data, and then try to analyze that using a kind of best practices workflow. You know, the way I got involved in that is actually through an undergraduate course that was taught by Rebecca Sachs. When I was in graduate school, I TA'd for her, and she did this in the undergraduate context. Now, it required, that kind of curriculum required some modification. You can't give a single student necessarily a project in the same way. But over the years, a bunch of us that teach replication pedagogy have kind of put together syllabi and materials that can help you bring kind of open science type practices into the classroom. These aren't specifically developmental, these tend to be broader, but it can be a really rewarding way to teach. And it can also be a way for kind of early career folks, me included several years back, to publish work from our teaching, both about the pedagogy and products from the pedagogy. In fact, we're actually, I and a number of my collaborators and former TAs for this course are at work on a textbook surrounding these sorts of issues that's intended to be an open science approach to experimental methods. So it's called experimentology. And if you, you know, it's about 2/3 written now. So if you come back to that name this summer, hopefully there'll be a full draft. They'll be available for you to work with and potentially adopt chapters from in your pedagogy.
Awesome.
Yeah, and I'd just like to add that at least Mike and I think some other Many Babies folks have talked about on our to-do list is to add like a teaching with many babies section to our website with resources that would be exactly what you're talking about, sort of providing slides and modules and like even a packet with like, you know, some data files that you could use to go through the processing steps that are on the website. So actually, I would love to talk to you about what you've already created. And we would love to make that sort of publicly available and make it easier for instructors to incorporate the Many Babies work in their teaching. Anybody else have anything to add on this topic or? Okay. Nicholas, why don't you just chime in?
Oh, sure. Yeah, I just wanted to note that there's an initiative called the Collaborative Replication and Education Project, which is sort of doing something similar to what's being described, which is large groups of undergraduates come together to replicate a democratically selected phenomenon. So it's similar to PSA, but at the undergraduate level, and it's led by Jordan Waggy, who's was an assistant director of the PSA for a while. But that's been a pretty interesting initiative, and I heard rumors that they might actually be getting a little bit of funding soon. So I could see that expanding and becoming very productive.
The Collaborative Replication and Education Project, and we can share out the link to that with everybody.
Other questions and comments for the panel?
Bless you. Yeah, we've reached.
I have something that I was thinking of when we talked about like the big takeaway. And yesterday I was meeting with some like industry big team science researchers, and they were applying for this grant, and I thought it was really interesting. They said big team science is really easy. Good big team science is really hard. Like anyone could like get together 1,000 collaborators and run the worst project ever. But what you need, you know, like what's necessary is finding ways to improve it. And I think that's been a really difficult issue to convince funders of. Like we can keep using Google Sheets to coordinate the largest studies ever done in the discipline. But the problem is like, it's not, can we do it, but could we do it much better? We could run far more complicated studies, get way more impressive insights if we could actually invest in a little bit of infrastructure. And when I think about doing good big team science, I'm thinking not only about the technological infrastructure and the staffing, but also the psychological mechanisms that lead to successful collaborations. And we're all here today because we've led relatively successful collaborations, but there are many large-scale collaborations that have not been successful, and people leave academia because of the fights that erupt, and their careers are derailed. And so understanding what makes projects fail versus succeed, and what makes, even within success, what makes some projects more successful than others, that I think could be really useful when it comes to trying to accelerate the pace a bit more.
Yeah. Go ahead.
I have a question about something that's come up about changing the reward structure, incentivizing big team science practices. I'm only a grad student, and I'm just wondering, how do you do this concretely and effectively and swiftly? Have any of you taken concrete steps, and how has that gone with, say, your departments or like at the university level?
So I'll say two things. One, I'm gonna say something that Martha behind you said that they have done at Colby, the last multiple searches, right, have specifically called out open science as a criterion. So I think that you get when you're doing faculty hiring or postdoc positions that are funded to bring these ideas front and center. Right? I mean, open science is not isn't equal to big team science, but they're related. And then in my department, we have an elected promotion and tenure committee, and I've been elected many times for my career. I'm on it now, and we explicitly put open science contributions as a section that we recommend our faculty candidates up for promotion or tenure to comment on in their narrative, and that we say that we will value that in looking at their contribution, presuming that the people downstream from reading our report may or may not appreciate what that means in our particular field, right? So that we start a process. So those are, I think, a couple of concrete things that can happen in department contexts, and we're by no means unique in that. I think there are other places doing things.
So just to add one thing on there, I think as scientists, we often think about kind of producing evidence and putting it out there in the world, and that's one way of thinking about the world. It's kind of a sort of a unidirectional approach. But when we start thinking meta-scientifically about the scientific ecosystem, we have to also start thinking about it as activists, not as evidence producers. And it's a fundamental shift in the way you interact. So if you're thinking about an issue like climate change, you might approach that both as an individual, like, do I stop using disposable shopping bags in favor of reusable ones? That's my individual choice. And is that too inconvenient for me, or is it kind of a small step that I can take? Do I purchase a different kind of car or something like this? But then as an activist, you have to think about what are the structures, what are the power structures that control the uptake of a policy? Like, should I be calling my local supermarket or the supermarket chain? Should I be posting, inflammatory things on Twitter, or should I be lobbying? That's always the answer. Or should I be lobbying my lawmakers, right? So you have to think about, okay, what are the structural sources of power that control the policy that I think matters? And that's for me, is a fundamentally different way to think. So as a meta scientist, I've had to start thinking about, okay, what parts of the ecosystem of science and scientific careers keep us from making progress towards the kind of goals and endpoints that are most important? Is it funding structures? Is it institutional structures, tenure and promotion or hiring? Is it journal structures? Where is that power where's the gatekeeping happening that keeps us from moving towards the scientific reforms that we want? Or are the problems fundamentally cultural, inside ourselves? So those are the kinds of ways that I think about these issues. I don't know what the right answer is, but try to treat this as an activist, where you have to you can't just go and yell outside any building. You have to figure out where is the right place to be standing there with your sign and yelling in order to make the maximal impact. And I think that's that's what the open science and meta science movement has kind of moved towards. And So hopefully brainstorming that way is the way to affect the sorts of changes that you are interested in.
Can I have one more data point to this question? And then, sorry, we can move on. I just want to say in our department, we've had, a few searches recently, and we explicitly had a conversation about whether or not, a top applicant seemed like a good departmental and or scientific community citizen. And open science was one of the topics that came up regularly. So the more we talk about this, the more y'all carry it forward in the future, right? The more common practice that might become, where it's something that you think about what makes a good scientist, what makes a good colleague. And then another thing to keep in mind is, although you're going to be author, 94 out of 160 or something on our, Giant Many Babies project, it's still an accomplishment that you can be proud of, and that is there as part of your, application materials. And it's so much less work than, being first author on a study that you, devote years to, in some cases. So there's still actually a tangible benefit to fairly minor contribution. And so there's a kind of inherent but small reward there.
Martha, yeah.
Back on that, so Rick and Casey commented about like, the things that more senior people can do to influence process, but at the same time, Mike's talking about lobbying, they grow to change their processes, and that's your job as the graduate student or the postdoc or the applicant to emphasize the importance of your work in that collaborative context, and that not what you actually did, but the fact that you were part of it and how this is like you're educating the readers of your application. This is the future of science, and you're only going to answer these big questions by using this methodology, and now because you participated, you know what's involved.
Yeah, it seems like proselytizing at all levels is important because, when I'm on search, I can say, no, this person's like 12 publications with them as a middle author, like that's not a bad thing, that's a really good thing. And, but maybe I am somebody who doesn't inherently see the value in this stuff. I might be able to be convinced by my graduate student who does, right? And so all of us can sort of proselytize where we're able. And of course, all of us recognize that those conversations can sometimes seem risky. I see it as it can sometimes seem risky, like when I was a junior faculty member. I can see how you might think it would be risky in some cases, but I think, if everybody's talking about this kind of stuff, then the risk to each individual conversation or person becomes much less, and hopefully we can all, get there.
Yeah, and I'd just like to say on an optimistic note, like going back to how Mark started his talk, like things can change, even though it's hard to change things can change pretty quickly. Like once I feel like we have a lot of momentum here in the attention that's getting paid to a lot of these issues, and these communities are growing. And so it's like at some point we'll reach a tipping point where there's enough people like Rick on hiring committees, like making that point, or there's enough people reviewing grants that can like make noise in their groups, and then it'll hopefully it's growing. And like the speed of these things is going to speed up as well. Like thinking of how the chart that Casey and Kiley showed with like how long it took for the first Many Babies project to get going, barring more pandemics, hopefully the speed of these things is also picking up as we get more of these resources in place and we learn how to do these things. We look at now, like Nick said, PSA now is able to, obviously data collection with adults is a simpler, but like they're able to do the process a lot faster because they have people that now know how to do these things. So I think the momentum is all going in the right way. We just have to make sure that it keeps going that way.
Well, and we have to be willing to say things that, projects that take 5 years, but that also have all of these built-in components that make it robust and strong. So at the end of the day, we can feel very strongly confident about the findings here. And if we aren't so confident, we can go look at them ourselves and convince ourselves that all of that requires more work and more time than the old, faster science, where things were a little faster and maybe looser, not necessarily, but quite possible. So I think that's also part of the message that has to be done, which is that doing these things with these other constraints of rigor and robustness and so forth is slower and longer and takes more people, more expertise. That's the reality, right? And there are other sciences, fortunately, alluded to them, that have seen that, right? There's nobody who's turning on the Large Hadron Collider themselves and running and finding particles that go faster than the speed of light, right? And publishing a 2-author paper in Nature.
Mark, Nick's been waiting to chime in. Go ahead, Nick.
Yeah, sorry, I just wanted to kind of weigh in because one of the projects I presented was actually my dissertation. So I did a lot of this work as a graduate student very early and had a lot of the same concerns that you have. And I kind of wanted to point out that I think they're justified. And I think it's very reasonable to be worried that change might be on the horizon, but it might not happen quick enough. And so I just personally think that it's very rational for people to say, will this work with like the incentive structure that I'm currently in? And even with that, even if we think that the incentive structure doesn't change, I think there are still some benefits that are sometimes overlooked. One of them is that, first of all, not everything has to be 500 collaborators. Even a 20 collaborator project is pretty big compared to what other people are working on. And in my opinion, my dissertation project ended up being far more rich because I engaged in a highly collaborative model. Because we were running such a big project, I basically had like a 20-person committee that was telling me, like, helping me refine the ideas and think a bit more broadly and connected to theories that I wasn't familiar with. So in my opinion, my dissertation work ended up being far more relevant to the field because I had such a diverse group of people who were sort of advising me on the way because they also wanted to get the project done. They also wanted it to be successful and informative. And so I think they helped maximize the impact of that work in a way that I wouldn't have been able to do by myself. The second thing I also want to point out is that I suspect that not everyone in the audience wants to stay in academia. And one thing that we've noticed in the PSA is that our graduate students and postdocs who are leaving academia are extremely competitive because everyone else that they're competing with is like, yes, I know how to collaborate with 2 people, but if you're working at places like Google and Facebook, you're going to be collaborating with a team larger than 2. And so these people who work on these big team science projects have a project management skill set and a social collaboration skill set that most people don't get at our level. And I think that that's an extremely valuable asset that even if it's not prioritized right now in academia, hopefully it'll be prioritized in the future, but even if it's not prioritized right now, there are other people who do see that value who will quite frankly pay you a lot more money for those skills as well.
Some great points. So we could, I think we had one more question and then maybe we'll wrap after Francis' question.
Oh, I was just gonna point out that Nicholas.
Okay, Mark.
Yeah, so this is maybe like a quick follow-up question for all of you on clarifying some of these issues, which is if we imagine a spectrum from like the standard paper that might have existed in developmental science 30 years ago, maybe 2 authors, to Large Hadron Collider, where do you think we will be? Where do you think we should be on that spectrum? And choose your medium distance 15, 20 years from now. Because I assume the answer is not all the way at Large Hadron Collider, right? There's those voices that are not present today as much saying, wait, but I think I can do some valuable stuff that's still small scale. So yeah, where will we and where should we actually end up as our goal state?
That question. Let me just say that we were talking about big team science today, right? Some of my richest experiences since I started in academia have been, yes, big team science and many babies, which I adore, but also what I might call little team science. And when I was a new faculty member, I paired up with one other lab pursuing similar work, and we've had grants together, projects together, papers together, lots of fun interactions together, right? And so I want to make a kind of plug here for, I just made this up, a little team science, 2 team science, right? Think of it as a spectrum from 2 labs you could just work with, or one other lab you could work with, all the way up to 207. How was on that first slide? Anyway, lots of labs. It can be anything in between, right? And there still may be great value in connecting with one other group and sharing best practices within your subfield. And so, that means, our group has some papers with, say, 5 to 8 authors pretty regularly, and then there's many babies, which of course many more. So I like thinking about this range, this spectrum.
Yeah, I'm looking around the room and seeing people I've collaborated with on papers that have plenty, an experiment that was run in one preschool and, has whatever, maybe not 16 babies or 16 preschoolers, but 30 or 60 or 70 or 90 collected by a single person. I think you have to have a mixed ecosystem where some discovery and exploration and innovation comes through rapid iteration. And then you have confirmation and precise estimation and exploration of variability. Not every project is right for Many Babies project. I have a lot of ideas that I would be terrified to have, 2 labs do, let alone 60, because they're probably a waste of time. But I'm interested to test them out and try them out. And so there has to be a mixed ecosystem. I guess what I think we are arguing is that the big side has been missing. So you don't get that precision, you don't get that rigor, and you don't get that exploration of variability. And often our questions are around those constructs. But all of the paradigms that we're exploring in Many Babies were developed in individual labs. I think, yeah, so certainly there's no push to eliminate the small. It's the small and the big need to coexist.
Yeah.
Go ahead.
I also think that, my vision for the future is that all of our small studies are themselves improved by the things that participation in these big studies have helped us see aren't that scary, right? So our small studies should be bigger when they happen in our own labs, and they should be more rigorous, all the things. And so I do hope that, and myself included hardcore, that my studies used to be too small. I hope we all move away from that stuff, but that generally speaking, aside from that we still have the spectrum, because again, lots of studies shouldn't be big team science efforts because it is costly, has enormous benefit, but you want to, for every individual study, what is the cost benefit of analysis?
I agree with all that it said. I guess I want to say that I think the number of authors on a paper is probably the least important part about it. Is it robust? Is it rigorous? Is it important? Are the questions important? And there are questions in our field we know that larger studies are important and necessary to answer. And so that's great, but that doesn't apply to everything. There was something, I guess, that you reminded me of. I should have started I meant to start my data management. Just all of the mistakes that you can possibly imagine that were in that I have made, right? And many people of my generation, we've made a whole ton of mistakes, right? And I like to think that you can teach old dogs new tricks if with enough reinforcement, right? And so I say that to you as to many of you as early career investigators, to say, appreciate that some of these recommendations come from I saved it on a USB drive. Yeah, I use hexadecimal. All of those. Yeah, we're laughing at it. But that's what I would like to see. 15, 10. I want our sciences to be as robust and reproducible and meaningful as I know they can be. That's my aspiration. And when we get there, I'll be like Justice Bryant. I'll know it when I see it.
All right, I think that's a great note to end on. One last thing I just wanted to mention before we break is, especially if you're a grad student or an early career researcher who's wondering about the experience of participating in these things, I just want to point out we've got Francis Yuen here. Give a wave, Francis. He's one of the leaders of the MB4 project. We've got Jessica Cosi over here, who's one of the leaders of the MB5 project. Martin Zetterston was also, he is still in the room. So he is also a leader of the MB5 project. So you can talk to them about what it's like to be very involved in these projects as a grad student or early career researcher. I think I thank you so much for coming today. Let's give a hand for all of our panelists. And please, don't be shy. Come find us, come talk to us. We'll be happy to keep the conversation going. All right, thanks everyone.